What if I told you there is a rock that is worth 10,000 quadrillion dollars? And yes, that is a real number. It exists, and when humans finally get hold of it, it will be very, very good and very, very bad. I'm about to tell you all about it, so let's rock. For centuries, daring explorers set sail around the globe on fragile wooden galleons, braving ferocious storms and ruthless pirates in pursuit of gold and silver that could build entire empires. Holds would fill with chests of silver from the mines of Potosi and gold from the Andes. Wealth so vast it reshaped global economies and triggered centuries of wars and inflation across Europe. Yet the dangers were immense. Hurricanes, scurvy, cannon fire from rival ships, but the promise of precious metals drove them onward. Because metals meant power, survival, and unimaginable riches. That timeless human hunger to explore the farthest reaches for wealth has never faded. And today a new generation of explorers are seeking riches on the final frontier, space itself. At the heart of this new rush stands 16 Psyche, a colossal asteroid orbiting 250 million miles from Earth in the main asteroid belt between Mars and Jupiter. Roughly 173 miles across at its widest point, this irregular potato-shaped asteroid is believed to be the exposed metallic core of a former protoplanet that was shattered by an impact with another cosmic object billions of years ago. Scientific consensus maintains that asteroid 16 Psyche contains 30 to 60% iron and nickel by volume, with traces of platinum group metals and possibly vast amounts of gold scattered throughout. NASA's Psyche mission, launched October 2023 on a SpaceX Falcon Heavy, completes its Mars gravity assist in May 2026 and then sets course for orbital matching, finally arriving to 16 Psyche in late July 2029. Prime operations begin in August 2029, with nearly 2 years of mapping, composition analysis, and studying how planetary cores form. This is not a mining mission, but is critical to unlocking solar system secrets for future mission. Early hype values Psyche's metals at 10,000 quadrillion dollars. Yes, quadrillion with a Q, enough to make every Earth citizen a multi-billionaire if we can extract and recover the riches back to our home planet. Even if the precious metals are less than expected, realistic estimates remain staggering. Iron alone potentially worth $1.5 quintillion, nickel adding 20 quintillion at current average prices, and platinum group metals throughout would elevate totals further, critical for batteries, catalysts, and green tech to supply humanity for centuries. And imagine, 16 Psyche represents just one prize among millions awaiting humanity's explorers. The asteroid belt is massive and filled with metallic M-type rocks loaded with the elements we need and value here at home on Earth. Near-Earth asteroids provide quicker access, smaller bodies passing close, ideal for early harvest missions without deep space asteroid belt travel. To help us get there, our moon holds billions of tons of water ice in polar shadowed craters, essential for rocket propellant and life support in space.
Lunar regolith also traps helium-3 from solar wind, a rare and important isotope useful for clean fusion power and quantum computing applications. Companies are moving quickly to harvest these resources. Interloon partners with a company called Vermeer on harvesters under NASA contracts starting in mid-2026, targeting 10 kilograms annual He3 extraction in the 2030s. Mars missions already being implemented are part of our first space mining exploration efforts as well. Mars offers volcanic zones rich in nickel, cobalt, and platinum group elements concentrated in its crust. While some companies head for the Moon and Mars, other companies surge ahead towards the asteroids. Astroforge's Deep Space 2 mission targets 2026 landing on a metallic asteroid to test PGM extraction. TransAstra's new moon study, also announced in 2026, plans capture bags to relocate small near-Earth asteroids, with their first mission scheduled for 2028 or 2029. First tested on the ISS in 2025, capture bags could slash costs by relocating resource-laden materials from risky areas into stable lunar or Earth orbits for processing. Space mining missions demand billions in spending upfront and years in transit to the target, but just one massive haul could eclipse any historical treasure ever discovered on Earth in value. So many benefits for mankind will be realized by space mining. Abundant platinum could transform hydrogen fuel cells, powering clean global energy grids. Nickel abundance will accelerate the production of EV batteries that are driving the end of fossil fuel dependence worldwide. And of course, massive amounts of iron and other base metals will be available to be used to build orbital habitats and starships in space, expanding humanity without scarring Earth. Profound environmental gains will be realized by halting destructive terrestrial mining, preserving ecosystems, and preventing pollution. But with such massive benefits, likewise the risks and hazards of space mining are severe.
US laws allow resource ownership after extraction, but no global or space-based global mining agreements or laws exist yet. The frontier revives historic prospecting and mining threats, such as claim disputes, theft, and of course piracy in a virtually lawless asteroid belt. Trillions in cargo and outer space treaty gaps invite rogue pirate ship hijackings and claim jumping. Extreme cold near absolute zero means huge risks of critical systems freezing and breaking, with no repair possible in deep space. Communication delays up to 40 minutes demand complete robot autonomy, no instant Earth intervention. Orbital debris and increased risks from constant spacecraft traffic in Earth orbit become new hazards, requiring careful management. Meanwhile, back on Earth, consequences can also occur. The influx of mass quantities of platinum, gold, silver, and nickel could crash markets overnight, devastating mining communities globally. Traditional miners in South Africa, Russia, and beyond face massive layoffs as supply chains fracture. Just as Spanish silver floods caused historic inflation, future asteroid abundance could trigger deflationary shocks, reshaping trade worldwide and beyond. Despite the many costs, risks, and perils, infinite resources prove irresistible, and the same human drive that launched Galleons now targets the stars. As the space mining age dawns, human history repeats on cosmic scale. From open seas to open space, our pursuit of unknown wealth continues. The challenges are immense, the risks profound, but the rewards will transform human civilization.
Space mining isn't a sci-fi dream. It's humanity's next resource reality.
Boom or bust, mankind's journey to mine the stars has begun. There is no turning back. Boldness wins the future.